Hi friends, welcome back again to the iSignal channel. So today, in continuation of the eNodeB log discussion, so we'll try to have a look at RLC layer after understanding the RRC aspect. So I'll just try to quickly give what we have done in the previous video. Example, you can see all the RRC messages like DL info transfer, UL info transfer, and the system information blocks, keys, security mode command. So I think you are usually familiar with the OTA messages, over the air messages. So then understanding the RLC is a little tricky because we have to map to the timings, and also it is based on two approaches that we can see in the previous discussions. Also I have already made an mentioned. So here you can see there are only two methods of analyzing the logs, individual logs, either in the timestamp sequence, that is number one approach, where unfortunately all the layers are actually present in this, or we can trace out that particular only layer specific. That's why you can see enode B, RRC, depending on the layer what we are trying to analyze, those things that we have to select and search in this, and so that we can get the results of the other things. So now right now we have decided to go for the RLC. So I'll just give RLC here. So find all. Now you can see all the RLC related contents. I'm just taking in the next new page. So here you can see now, in order to analyze these things, okay, we should have a little time mapping. I'll just try to give a glimpse and understanding about the time mapping, so that you are familiar with in what stage of L3 call or in what stage of RRC layer message exchange the RLC is making an attempt and doing according to its own protocol specific rules, which is written in the 36322 RLC specifications, LTE specifications. Now I am just starting with the initial thing. Okay, so here you can see, let's try to have a look at RRC here. Example, let's say this is one message DL info transfer, which means when we are going from RRC to RLC and MAC and physical layer, it means in the down direction, right? Either it is from UV or the eNodeB side. So what are the different message exchanges, what all the different layers are involved, that we have to know in a very careful manner. Okay, example, you can see RRC is here. Let's say this is the timestamp. So you can easily get this timestamp from the actual base station log. So here eNodeB log is the bigger log, and we are trying to analyze only RRC, or we are trying to analyze only RLC. Example, whatever I have taken from RRC now, this is the timestamp 579096, whatever I have highlighted, so that we will get definitely here in the base station log. So I am having base station log here, same thing. Now related to this, near to this, right, what is the next RLC here? This is the RLC, right? So these things we can definitely get in the RLC, because this is a bigger base station log and we can get it in the RLC. Now you can see this is the RLC. So for the corresponding RRC message, which is DL info transfer, the down layer, which is RLC, is here, which means it is acting according to its own protocol rules, right? So you can see all the RLC. This is sequence number 0, right? And other one somewhere they would have mentioned actually, and this is the number of bytes. RxPDU, TxPDU, wherever it is RxPDU, it means you are actually expecting the data from the UV, because this is base station log. And wherever you see TxSDU, TxPDU, right, this is like base station is trying to send. Now base station is trying to send in this particular instant of time 46 byte it is trying to send, and you are receiving status. So for the sent one, what is the acknowledgement, whether it is negative acknowledgement or positive acknowledgement? So negative acknowledgement is 0, means you have received it successfully. That is the main thing for this particular sequence number. So like that for every sequence number. Okay, I'll just take again this particular sequence number, right? So I wanted to trace out at the base station side. Here what I'm trying to do at the base station side, whether I'm receiving the sequence number perfectly or not. With this we can consider, okay, there is a delay or there is a crash, there is a retransmission, there is a negative acknowledgement, right? There is whether to maintain the retransmission buffer or not, right? All these things we will come to know. So here, if you are receiving, it may be an out of order we might receive, but at the end of the day we are actually receiving all the sequence numbers or not. That matters a lot. Now here you can see RX data PDU SDN, PDU sequence number, which means all the sequence numbers from the UV at the base station at the RLC level, whether I am receiving or not. This is what we are actually going to confirm now. Okay, I have just clicked now, right? All the sequence numbers are coming, RX data, RX data. Now you can catch 1023 sequence numbers, right? So just go there, right? These are all basically all the sequence numbers, everything. If there is any missing, then there is a little bit of a delays, right? That affects the throughput definitely. Okay, so basically until here you have seen this is only up to RRC1, sorry, this is SRB1 and SRB2, which is related to control plane. With respect to the control plane, with respect to the RLC messages, how my RLC is behaving, these are all handling of SRB1 and SRB2, that's all, right? And right now from here, DRV1, the sequence numbers, now it's from 0 it will start. So it is going, there is no miss, right? 10 level, 12, 13, 20, like this, 40, 50, 60, 70, 80, right? Like this until 1023, because it is 10-bit sequence number, right? That's why it is 1023. All are 88, 89 bytes, 176 bytes, depending on the data, right? It is going through, which means these are all like YouTube packets, WhatsApp packets, right? Sequence numbers. So which means my RLC is actually entered into TM mode also and AM mode also of control plane. Now AM mode of user plane. Now in the AM mode of user plane, DTCH traffic, which means the DTCH logical channel, all these things are actually going through. My DLSCH, right? Sorry, this is ULSCH, sorry, because RX, which means UV side you are actually sending, which is in ULSH arc. That is one aspect that we have to identify and analyze. And another aspect, example, you can see no data available, right? It means there is no data here. And another one example, here VR of R, right? This is one more important aspect, VR of R in RX SDU. One more, there are so many different segments, 87, 86, 86, 86 segments. These are all segments. So remember, I think if you try to recollect from the RLC specification, there are concatenation, segmentation, reassembly, segment, right? These are all the different functionalities in the AM mode of operation. Pole byte, right? Pole PDU, RX, TX, status, control PDU, data PDU. These are all the different aspects. If you try to have a look at 36322, you will come to know. Accordingly, this functionality has been written, and in the logs you can see those things update, right? Year of UR, correct? So here there is no complexity actually in understanding related to this, but the point is we should correlate basically, because at the OTA level what is actually happening at the OTA level means we will predominantly see only the RRC logs. Example, you can see RRC, let's say this one, DL info transfer, right? This is RRC. Against this, what is a timestamp? Then only you can easily identify, then only you can easily identify the things. Okay, so this is actually RRC related thing. So but maybe you can see again, we will go back to this and try to analyze, right? PDCP related, this is the timestamp. So with respect to this particular timestamp, the mapping timestamping the RLC is this. So this is a very easier way to analyze and understand at one particular level of RRC. What is the situation of RLC? Whether the sequence numbers are proper, whether it is acknowledgement, negative acknowledgement, retransmission is happening or not, in order to fulfill that particular thing. Example here, DL info transfer, you are sending some message in the downlink, right? So for that, for the RLC, where how many sequence numbers are planned, what is a PDU, what is a PDU size, what is a payload, what is a header, whether it is a status, whether it is a transmission, whether it is a retransmission, right? All these things that we have to analyze and see. So how we can analyze, if with respect to particular RLC, we can choose the timestamp and go here and there, top to bottom timestamp. It will be there, and just check in that particular timestamp in the that particular timestamp in the this file. So this timestamp example here, this timestamp, correct? So sometimes it is very difficult to analyze in a whole set of log. So until and unless we filter, we cannot able to see the logs. So exactly this is how we will see the logs in the Qualcomm tool, QXDM, QCAT, right? And also ELT tool from MediaTek and other things, other company tools. Okay. So this is how we can see the RLC logs actually. So you can see here SRV0, SRV1, right? These are all related to control plane operations. Until here there is a control plane operation, until here there is a control plane operation, right? For that the sequence numbers are also there. Negative. First acknowledgement, sequence numbers, sequence number 1, sequence number 2, right? 7 bytes, 10 bytes. Transmission and reception we can see easily. But wherever you see TX, those things, wherever you see RX, those things that you can expect again the same thing in the UV side. So that we will see in the another video. Just a simple example I'm just trying to show in the next upcoming videos. Then we'll try to see. Then you can easily able to correlate at that particular instance of time. UV and base station both are actually communicating, and we can see one particular layer and peer-to-peer entities, how they are actually trying to communicate. Then we will come to know all those things in a very clear detail. Okay, so yeah, so that's it for today's video. So and we'll come up with another layer in the next video. Thank you again. Yeah, bye.